Good morning, Tahmina Khan is here in TKMaths is fun. In today's video, I'll explain to you a concept of A-level mathematics M1 paper 4, and it is about resolving forces on a straight line. This question is challenging because there are two more concepts which are merged in it, not only resolving forces, but use of SWAT equations and use of Newton's second law, F is equals to ma, is also applied here. So before I begin, this question is taken from November 15, variant 41, question 5. So you can see on the top my two blog addresses. One website address, tkmaths.com, and other is my blog address, tkmathsisfun.blogspot.com. Do visit it. This site has a lot of information. It is still under development. As requests are coming, I'm developing it gradually. And TKMaths is fun has all my previously made videos. So it is very user friendly. You can find the video of your choice of whatever you need from here. So let's begin with the question. So in this question, the length of the wire is AB, which is 3 meters, and three forces are applying on it, which has magnitude 20 Newton, F Newton, and 10 Newton, and angles are mentioned here. This is along AB, 0 degree. This is 70 degree along AB, and this is 30 degree along AB in this direction. And R is the resultant force, magnitude of the resultant force. So this is given to you in the question. Now question is asking you, it has two parts. Part one is find out the value of F and R. And second is that initially the bead, this is the bead, right? Given to you here at the point Q right now. So initially the bead is at rest at A. We will considering it is here. And then when it reaches here, the speed is 11.6. So we have to find the mass of this. Okay. So let's begin. First question, part one, find the value of F and R. Now, if you see here, before I begin, I want to give you this piece of information. Whenever I explain this in the class and write directly, students get confused. So what do I write? For example, I draw the diagram and this hypotenuse is, for example, F Newton. I said, so what is this? Because I'm resolving it, I'm resolving it horizontally and vertically. So I said what this component of the force will be. I directly write F sine theta and I write here F cos theta. So this is how. So if you see here, sine theta equals to A upon F. Sine theta is opposite over hypotenuse, and cos theta is adjacent upon hypotenuse, which I have written here. So if you manipulate it, A is equals to F sine theta and B is equals to F cos theta. So that's why we remember it is hypotenuse times cos theta for adjacent, and for opposite it is hypotenuse times sine theta. Okay, so remember this because I will make use of this in the question. Okay, so now this is the figure given to you. I have resolved all the forces horizontally and vertically. So let's pick up 20 Newton first. Now 20 Newton is along AB horizontally. There is no vertical component of it, so I'm not touching it. It has only horizontal component. If you look at force F, which is making an angle 70 degree with AB, okay, up clockwise, anti-clockwise, sorry. So horizontally it will be this and vertically it will be this. Okay, so now this horizontal force will be F cos 70. I've just explained to you here how. And this vertical will be F sine 30 or 30 carrying, I'm sorry, 70, right? Similarly, if you look at this 10 Newton force, which is making angle 30 degree here, when I resolve it horizontally and vertically, it will be this. Now horizontal force will be, hypotenuse is 10 and this is adjacent, so it is 10 cos 30. And this will be hypotenuse times sine 30. So it is 10 sine 30. So I got the horizontal and vertical component of force 10 Newton also. Similarly, the resultant force, which is R Newton, if I resolve it horizontally and vertically, it will be this blue line, okay? So horizontally it will be hypotenuse times cos 15, and hypotenuse is r. So it is r cos 15. And this vertical will be r sine 15. So I have shown you here all the forces I have resolved horizontally and vertically. Now, conventionally, when we talk about left side direction, we take negative, right side positive, up positive, right negative. Actually, it is opposite sides, opposite angle. So if you are taking other way around, there is no harm. Okay, but be careful, opposite sides, opposite angle. But I'm using the convention uh, marks, signs used to of it. Okay, so let's see. So R is the resultant force of the three forces, and we have resolved horizontally and vertically. Now we will do addition. Okay, so horizontally, if I see, because three forces are equal to resultant force, so let me pick up, for example, this green one is 10 cos 30. I'm using minus sign because it is on the left hand side. I'm picking up all horizontal forces right now. Okay, so this green is pointing left, blue is pointing right, 20 is pointing right, red is pointing right. Now the blue is resultant, so that's why it will come after equals to. Okay, so I'm doing minus 10 cos 30 plus f cos 70, because this is horizontal component, and the black is 20 Newton. So I've written here 20. I have written here 20 as it is, and they're equals to horizontal component of the resultant force, which is r cos 15. Okay, so these are the horizontally resolved, and now vertically. When we will resolve vertically, we see this red line up, green line down, blue line down. The blue is resultant, which is r sine 15. So that's why I'm writing it equals to. Now I'm using minus sign because it is pointing downward, right? Now let's see this. This is 10 sine 30 downwards. I'm writing minus 10 sine 30 plus what? F sine 70. So I'm repeating here that resultant is like the sum of all. So when I'm talking about vertical forces, so this blue one is equals to sum of red and green, right? The directions I have taken because, I mean, plus or minus sign I have taken because of their direction. So I hope it made sense to you. So this is green, red upward plus green downward. Now why did I write say plus? Because basically we are adding two forces, but it has sign negative. Okay. So now we have resolved horizontally and vertically. Now we will solve them simultaneously to get the value of F and R. So you just need to do calculation here and be very careful. Now I have used cos 70 or sin 30, whatever the angle is. I'm not using decimal values. If I will use up till 3-4 decimal places. Why? So that my final answer in three significant figure is close to the requirement. Okay, so from equation 1, I have made f cos 70 a subject, right? So I've taken 10 cos 30 on the other side. You can see here, it has become plus. 20 I have taken to the other side, it has become minus 20. And after that, I'm making f a subject, so cos 70 is going underneath division. Now this, I have manipulated equation 1 and I'm plugging in equation 2. So I will plug in here. So whole this value I have written in blue and I'm plugging in here in place of f. Okay, so you can see in place of f I have written this whole value in blue. Then it is sine 70, then minus 10 sine 30 as it is, and equals to minus r sine 50 as it is. I hope you know how to solve simultaneously. Only such big substitution confuses a student at times, so you just need to be careful, and that's all. So now I'm plugging in the value 5 root 3. I'm not writing decimal still. In the next line I'm writing it, but you see up till 4-5 decimal places to be more accurate. Okay, and then r cos 15, sine 70 divided by cos 70 is tan 70. So I'm simplifying it, and the rest I'm writing as it is. Okay, this is 30. Do not mix it up with 80. Look like 80, sorry. After that, I'm multiplying tan 70 with the calculation of this, I got this answer. Okay. And then it is R cos 15 times 1070. I have taken this whole value on the other side of the equals to. That's why it has become minus. Here it was plus. And then I have taken this also on the other side. Okay. Sorry, I did not. I have calculated it, right? So basically, I'm simply calculating it. You can do calculation with your pace if you want to do one thing at a time, like only want to multiply this, then this, then this. So you can do all this. This answer is basically the calculation of this whole thing, right? Okay. So now I have calculated the value of R here. So after calculating the value, I'm writing it in 3 significant figure. I'm writing here in more decimal places in case if I need to use it later. Okay. Now let's see the next slide. So now I'm plugging in this value of R in this equation, right? Which was taken from previous slide. So after substituting, I have shown you here the substitution here in place of R. Whenever you're using a value, do not use rounded off value. Use the value, actual value up till 4 or 5 decimal places to get the next answer more accurate. Okay. So now I got the value of F here. So I have found F and R here. Now we will go to the next part of the question. So part 2 of the question was saying that initially the bead was here. When it reached here, the speed is 11.7. So find out the mass of the bead, right? So now you need to recall here. I have it and I would recommend this to you also. Whenever you're reading a question, pick up all the information and put it down here like this. It helps you not to make any error. So AB length 3 meter, at A the velocity is 0, at B the velocity is 11.5, 11.7, and I have to find mass. Now if I have to find mass, it means I need to use this equation, Newton's law, force is equals to mass into acceleration. So mass I have to calculate, but do I have acceleration right now? I don't. So that's why first of all I will use SWOT equations to calculate A. Now there are more. There's one more SWOT equation. I was just writing here to recall, help you recall it. Okay, what are SWOT equations? So I will make use of this equation here because both velocities are given to me, distance is given to me. In this equation there is time. I don't have it, so I don't want to go into that detail. So straight away this equation can help me finding out the acceleration because all the values are given here. So let's make use of this equation and solve it. Just look at this side first of all. Let me open this side. Okay. Okay. So I am substituting the value of V. I'm substituting the value of U. This is point A. This is point B. See, I wrote down the information here. So after that, distance was 3 meters. So I got acceleration 22.815 meter per second square, meter per second square. Okay. And then I'm using Newton's second law. F force is equals to ma. Now force is R cos 15. Do you remember how? Let me show you again if you have forgotten. Because if you remember, this horizontal component of resultant force was R cos 15. Let me show you here. Here. Remember, this resultant force is R cos 15, right? So this force is my forward force, which is making the bead move. So now I'm using R cos 15 is equals to MA. And my R value I'm plugging in here and then getting the value of mass, right? So R is your 12.271. So this is how you will calculate the mass, and mass will be in kg because the units are Newton meter per second, so mass is in kg. So thank you very much for watching the video. I hope you have learned this question, and it's not only about solving the question. I want to explain the concept so that you are able to solve more question on your own. So please press like and subscribe button if you have learned something, and share it with your friends. Take care. Allah Hafiz.